The last few things to do, soldering up the final connections on the front panel controls, connecting the input jacks to the tubes, and this amp should be ready for voltage testing. I have to put a jumper from the channel 2 bass control pin 1 to the middle control pin 3. I also have to put a jumper from the treble middle pin 2, to volume pin 3. We also have to connect coax from the gain middle pin 2, to V2 pin 2, and that will also complete the soldering of the 330 picofarad capacitor here. The shield of the coax will connect to this tab, tab 1 on the gain control, and it does not connect at the other end. So the shield is only grounded at this end. At the other end of the coax, we will just put some heat shrink on, leaving the center core exposed but covering any whiskers that may be poking out of the shield. We don't want those shorting on anything when it gets connected to V2. After that, we need to connect the control ground bus, which will go from the middle pot, tab 1, then that jumpers over to the gain pot, tab 1, then over to the volume pot, also on tab 1, and then from there it will go over here to the preamp ground. Then we will wire the input jacks. I'll show you that in a minute. We're just going to move on to what needs to be done on channel 1 now. We need to put a 47 picofarad cap from tab 1 of the tone pot to tab 1 of the volume pot. And then from tab 1 of the volume pot, we need to take a ground over to the preamp ground point. We need to just wire up the input jacks for both channels and run their connections over to V1A and V1B. So I'm just going to detail that a bit using the layout here. It's exactly the same procedure for the input jacks for channel 1 and channel 2, except they have different connections to different sides of the tube. Looking at the inputs for channel 1, we have a high and low input. We need to do a ground connection across all of the tabs at the front of each jack. So we have a ground that will go from here to here to here to here. Then that ground jumps over to this tab of the high input jack, and then also a ground goes off to the preamp ground. Also, we have a 1 meg resistor from this tab to this tab, and we have a jumper going from this tab to this tab on the input jacks. From there, the outputs from the jacks, we have coax, a gain with a shield grounding to the common ground point here on both of these, and at the other end that ground is just heat shrunk off. It doesn't connect to anything at the other end. The center core though connection, for example on the high input, goes from this tab and goes all the way to this terminal strip, which then connects to the 68K going to pin 7 of V1, that's V1B. We also have a coax coming from this tab going over to this terminal strip and through a 68K also to pin 7 of V1B. When I say V1B, 12AX7 preamp tubes have 2 triodes in them, so basically 2 devices in the one tube. So V1A is just used to designate one triode, and V1B designates the other. So on a 12AX7 there are 9 pins. Pin 1 is the plate of V1A, pin 2 is the grid of V1A, and pin 3 is the cathode of V1A. Then pin 4 and 5 are the heater power supply. Then we get to V1B. So pin 6 is the plate of V1B. Pin 7 is the grid of V1B. And pin 8 is the cathode of V1B, and then pin 9 is the other heater connection. That's what we mean when we say V1A, V1B. So that's the detailing of the inputs for channel 1. It's the same for channel 2, except that the coax goes to this terminal strip here, which then connects to pin 2, the grid of V1A. I'm going to also show how I wire the inputs. I'll just show wiring the inputs for channel 1. As I say, it's the same procedure for channel 2. They just go to a different place. After that, I will go off camera, finish all of this wiring, come back, we'll do the run through of what's been done, and then we should be ready for the first testing of voltages. Well, I said in another video that there's a certain easy way to wire up the input jacks on the amp. I'm actually showing you two ways. One is the way I usually do this, and one is the way I'm doing it that's easier to show you guys the wiring on the jacks. So the way I normally do this, and many other people do, is you can see here I've taken these jacks out and I've put them in backwards so that they're the tabs are on the outside. That way the jacks are spaced the way they're going to be when they go into the chassis, and you can wire up all of those connections and all of the wires going off of those jacks to the board and the ground. You can just estimate length, leave those long. Then when you're done, you can loosen these jacks out, take them out, turn them around, and put them back in, and then you can wire the final connections to ground and over to the terminal strips over here. The low input is the one that goes on the bottom of the chassis, and the high input is the one that goes toward the top of the chassis. So of course we're working on this chassis and it's upside down, so the low input from our perspective right now is on the top and the high input's on the bottom. Of course when the chassis is turned in playing position. So that's the way I normally do this, but it was a little bit difficult to kind of show you that. So the other way to do this is, as you see here, what I've done is I've taken a box, a cardboard box, and I put two holes in it. I spaced those by putting it up against the chassis, marking where the holes were, and then putting the jacks in. This is the low input, this is the high input. So when we wire this, first of all, it matches what we're looking at on the layout diagram, so low and high. Also, when we put this back in the amp, we'll take this out, we just turn it up on end and put it back in the chassis, and everything should be good. We need to put a ground across all four of these tabs, and then that ground has to come across and go to this tab. So that's that ground wire installed. We also have a 1 meg resistor that's going to go from this tab to this tab. So we'll put that in, and then we can solder these four tabs together. We have still other things to put in these tabs down here, so we're not going to solder that yet. Okay, so with the coax cable, as I said, one end, the shield, the ground, will go connect to this ground point here, and the hot will connect here. Also, there will be another one going with the hot here and the ground to here. At the other end, where it connects to the tube, we won't be using that shield. We won't be connecting that to anything. So we need to get the core wire out of there, trim this shield back, and then heat shrink this. So how you get the wire out of the coax, take a little jeweler's screwdriver and make a little hole in the coax braid. Just by pushing the wire out of the way, the braid is pushed aside, and you can see the inner core wire. So what you have to do is fish that wire through that little hole. Okay, once you've done that, make sure you've got any stray strands of the shield out of your way, and you trim this as close as you can to where the jacket is. We'll use a little bit of 1/8 inch heat shrink, cut about 1/2 inch of that, and we will put it over this jacket, and then we're going to just shrink that on. For this end, we're going to do the same thing. We'll make that little hole and fish the wire out. But this time we're not trimming off the shield. The shield needs to go to that ground point. So we will twist the braid. Don't twist the braid so tight that it's snug against the core wire, because when we solder this, the heat could cause that to melt through the jacket of the core wire, and then we'd have a short, and we'd have a jack that doesn't work. We're going to trim this to connect the core wire to this pin, and then the ground side will go to here. So I'm going to trim those to about just a little bit more than half an inch long, I think. So that's all the wires soldered on to the jacks. Just going to take this out of this little jig and check that all the connections are good and solid, and then we'll put them in the chassis. I've wired up the input jacks and then installed them, and I've run the coax cables over to V1, and also there's one piece of coax that comes over here to V2 from the front panel controls. Again, nothing special there. You just connect them, just the center core wire to the pins on the tubes. And the shield is not connected to anything at that end. You only ground your shield at one end, or you will get hum issues. So the whole amp is done. The procedures for firing up the amp, which is what we're going to do now, based on the instructions, the first thing that is suggested is that you fire up the amp again without any tubes or anything in. So that won't draw anything, but you can test all your AC voltages that way. I've done that already. I also did it when I put the new power transformer in there. There was no change between now and then. The AC voltages are all looking good. The AC voltages will be high at all those test points until you get tubes in the amp. There's nothing loading down the power supply, so there's a lot more potential there, and you will see higher voltages. So following along with the instructions, the next thing they suggest is to put just the rectifier in, so you can check your B plus just before the first filter cap here, so you can be sure that you're in the right range of voltage there. If that all looks good, you install the tubes, and then you check all your voltages throughout the amp. If that's good, you're ready to play. I now have the rectifier in. There's no need to load, to put a speaker load on the amp yet, because we don't have any tubes in, so the power's really not going to go anywhere. I'm going to put it on the bulb limiter. As I said in a previous video, at this point the bulb limiter is not really going to tell you much, because you're not really drawing anything. But if you have a direct short somewhere, the bulb will light up bright, so you will know you have a problem. I've got the bulb right up here, so you can see what's going on when I turn this on. Everything's plugged in, current limiter's engaged. We'll turn this on, and nothing happened on the bulb as we expect. The amp's still on standby. So we're going to let that run for a few seconds, maybe a minute or two, to make sure the rectifier is operating. Of course, because it's a tube as well, it needs to get the heater needs to get everything up to appropriate temperatures so that the rectifier does the job it's supposed to do. So we've got that on. You can see from the top-down camera we have the indicator light is glowing, and I have no smoke. We're good to go. And you can see we had no brightness on the bulb here. You should be able to see my meter down here. I've got it set on the 700 volt range. So all I'm going to do right now is just check the voltage at the filter cap, the B plus, just before it goes into the filter cap. We're seeing about 410 volts DC there. So that's looking good. No noises, no smoke. Everything's looking good. So I'm going to turn the amp off. Flip it over, put all the tubes in, and then we'll put it back up. I will connect a load to it because now we will have tubes in. It will need a load of some sort, and we will check all the voltages through the amp. So we haven't talked much about what tubes I'm putting in. I got really lucky a few years ago, and I had bought an old tube PA amplifier, basically to salvage for parts. And when I opened it up, there were 6 or 7 of the very sought-after Telefunken tubes. These would be from the late 60s, early 70s, and they were all in a PA system that had been used, at one point. But checking all those Telefunken tubes, they all measured good. So I've been saving those for a project to put these in, and this is where they're going. So I've got 3 Telefunken 12AX7s installed into the amp. Also, I just recently found a dealer of new old stock vintage tubes here in Canada, my country. He's in Victoria, BC, I believe. And I've got a couple of absolutely brand new out of the box RCA 6v6s. There were no scratches on the bases or anything. These clearly were built, I believe, mid-60s these are from, and had never been used. And they were tested. They're guaranteed to be working. And so I thought this amp deserved to have some nice new old stock tubes in it. And always your new tube sockets are very tight, so you can have a little bit of a fight in installing everything. As I said, I've got a 5AR4 rectifier in here right now. I also have a solid state rectifier cap that I could put in there, and that will bring the voltages up in the amp a bit. Solid state rectifier stiffens up the power supply a bit and makes the amp sound a little tighter, so it doesn't have the sag. With a tube rectifier, the harder you play, the more draw you have on the power supply, and the power can sag with a tube rectifier, and that's part of the sound of a vintage amp. If you like a tighter sound, which I do, using a solid state rectifier will be one of the things that helps tighten up the sound of the amp. And I have a 16 ohm dummy load. Actually, it's a combination 4 ohm 16 ohm dummy load that I built for testing here in the shop. So I've got the amp set to 16 ohms. Yes, I am sitting down while I do this. I'm going to stay on the edge of the chair and well back, and I'm going to be using the probe. I'm not going to be getting my hand in close to the amp. I'm just going to turn the power on, not the standby. We'll leave that in the off position right now, but I'll turn on the power, and we're just going to, again, let the rectifier and the other tubes come up to their working temperatures before we turn the standby on. So watch the current limiter. You may see that bulb go bright as I first turn this on. And there you go. You see it goes bright, and now it's dimming down. That inrush, everything's charging up, and you see that the bulb limiter has gone back dim. From the angle I'm at, I can't see it. I'll take a look. We're going to let the amp come up to temperature, and then I will take it off standby. Once again, when we do that, we will see the bulb limiter may brighten up somewhat, and then it will fall back. It won't go fully dark, and then we'll take it off the current limiter, and we'll start doing some voltage measurements. So this should be good enough now. We'll take this off standby, and there you see it bright again. It won't go full dim. I'm using a 60 watt bulb in here. If I were using a higher wattage bulb, it would go dimmer because those have lower resistance. But I did not have a higher wattage bulb. So the other thing that you might note when you do this, and it's different for different amps, this indicator lamp has gone very dim. To you, it probably looks like it's even not on at all. It is on. It's on very dim. So first thing I'm going to do, even with the current limiter on, I'm just going to check what voltage we have coming into the amp. Yeah, and we're down at about 74 volts, so we're quite low, and we should see 74 volts across this indicator lamp as well. Yeah, so we got about 74 volts both at the input and at the indicator. So that's why the indicator lamp is quite dim. On the Triwatt, when I did this, the bulb stayed pretty bright. So that will vary amp to amp. So we've been running well enough. I've got no sparks. The bulb limiter is not on bright. So I think we're in good shape. I'm going to turn the amp off and then switch the current limiter to full power. So the amp is on. Indicator light is bright. No strange smells, no noise, no sparks, nothing like that, no smoke. We're just going to again let the amp come up to its operating temperature before we take it off standby. And then we're going to do measurements. And we have about 12 or 15 points that we're going to measure. Some will be AC, some will be DC. So we're going to make those measurements, and we're also going to note it on our sheet. If you don't have a sheet that lists all your measurement points, make one up and just write your initial findings down on that sheet. So the first thing that we're going to do is our AC measurements, and we're going to measure across the IEC connector between the neutral and line connections, and we should have about 120 volts AC there. We also should have about 120 volts AC across the indicator lamp. So these are the first two measurements we're going to take. So we have power's up a little bit today. We're at about 122 volts at the IEC connector. Across the indicator, about 122 as well. We should see the same at both. There's not really any difference between those two spots. We expect 120, but this is wall power. Wall power can fluctuate quite a bit. I've seen wall power get up pretty close to 128 volts. I've seen it go as low recently as 115. It doesn't often go below that anymore. So the next thing we're going to do is we're going to read across the rectifier pins 4 to 5, and that's where we're going to see high voltage. And we're getting about 615 volts there. We expect to see about 580 there. 615 is not super over, considering the incoming voltage is a little bit higher, and all these components operate within a certain percentage range. I'm not concerned about that being at 615 volts there. The next thing we're going to do is read our heater voltages. So on the rectifier, we should see 5 volts AC between pin 2 and 7 of the rectifier. And then at all the heater terminals through the tubes, pin 2 to 7 of V5 and V4, the output tubes, we should see 6.3 volts AC. We also should see the same 6.3 volts AC on V1, V2, V3 between that pin 4, 5, and 9 connection. So we're going to measure those now. Pin 2 to 7 of the rectifier. And we should see about 5 volts. Yeah, we're getting about 5.26 volts there. And now we'll measure the heater on the output tubes and the 12AX7s, and we should see about 6.3 volts AC all the way through. And yeah, we got 6.7, 6.7, 6.7, 6.7, and it's a little difficult to get at in here. I'm not going to be too concerned about measuring V1. Those pins are underneath a whole bunch of other circuitry, and I don't want to risk shorting something in a live amp with the probes. When I measured this before I wired everything, the string was fine all the way across. I'm confident that there's 6.3 volts there, or 6.7 as we're measuring right now. So we'll just note that, and then we're going to measure DC voltages. This is where to be super careful, because we're going to be measuring a lot of high voltages that really pack a wall up. So if you don't know what you're doing, you probably want to have a tech check these things out. Even if you've built the amp, if you're not confident working around these high voltages, especially these high DC voltages, have somebody else check it. I'll turn the amp off and connect the negative probe to ground, because all of these voltages will be referenced to ground. Then I'll turn the amp back on and we'll measure these points with a probe, and I will keep one hand behind my back and I will be standing up. So the way the amps are built, there are bleeder resistors that will bleed any stored charge in the capacitors off to ground once you turn the amp off. But never take the chance that there isn't a charge still remaining in the power supply. We will be measuring the voltage at B+ again. We're also going to read the plate voltages on all the pins. So V5 and V4, the output tubes, that's pin 3. One thing I will point out, in the builder's guide there is an error. They say that for 6V6, 6L6, KT66 and EL34s and those style of tubes, that the plate is pin 8, and that's incorrect. On 6V6, 6L6, KT66, EL34s, the plate is pin 3, not pin 8. Pin 8's the cathode. So that is an error in the instructions. I will be emailing Stephen about that. And the first thing we're going to do is measure the voltage at B+ before the first filter cap. The builder's guide says to expect about 386 volts DC going into the first filter capacitor, and we are getting 371, so we're actually a little low, and that's okay. So we've got 371 volts B+. Next we are going to measure pin 3 of the output tubes V4 and V5. Pin 3 on V5, we got 359. Pin 3 on V4, 361. It's not unusual to have an imbalance in the voltages between your output tubes. If the plate voltages on your output tubes are within a few volts of each other, that's nothing to worry about. They don't have to be exact. You kind of would expect them to be exact, but that's a theoretical construct. So a few volts difference between the two is not a problem. The next thing we're going to do is measure the voltages at pin 1 and pin 6 of all of the preamp tubes, the 12AX7s. Some of the circuitry is pretty tight, especially on V1. If you can't measure right on the pin, find where that voltage comes from and goes to the pin, and then measure there. We're expecting to see 168 volts. So this is the wire that feeds pin 1, and we are seeing almost exactly that. We're seeing 167. At pin 2, we want to be seeing 127. So that's this turret here. And we're seeing 128. So I'll just note that on my chart. On this tube, V2, pin 1 is fed its voltage through this resistor. So your voltage comes into pin 6 through this wire from this turret here, and then goes through this resistor, and that's how pin 1 gets its voltage. So we're expecting to see 145 volts DC on pin 1. 141, very close. At pin 6, we're expecting 240 volts. And we're seeing 231. The last two measurements are for pin 1 and pin 6 of V3, the phase inverter. We'll be expecting 188 on pin 1 and 184 on pin 2. And we can measure those right here on either side of this capacitor here, these turrets. So pin 1 here, we are getting 169. And pin 6, we are getting 173. So across the board, we're seeing our voltages a little bit lower than the builder's guide would suggest. Again, that's not abnormal. Things can vary. So I'm good with this. So I'm calling that a successful build. The amp fired up, no smoke, no sparks. Rather uneventful build, other than miswiring that first power transformer, but that was a quick and easy fix. A little bit expensive. So I'm calling this a successful build. All the voltages are good. The amp is sitting here cooking away and working just fine. So the demonstration video of this amp, I'm going to take a couple of weeks right now and to sit and play with this amp and get to know it before I do a demonstration video of it. A couple of videos back, I also put a little teaser in one of the videos that said, hey, what happened to the double mystery pedal build? Well, I got a little bit into a crunch at the end of that build and wanted to get started on this one. So I decided that what I would do is demonstrate the mystery pedals and this amp both in the same video. So the demonstration video for this amp will also have the mystery pedals at that time. So like I say, I want to sit with this amp for a couple weeks and then I will film a demonstration of this and post that. My channel might be quiet for the next couple of weeks, maybe a few midweek musings or maybe a short video on something else. But the demo of this is coming up soon. So like always, thanks for watching. Like and subscribe, ring that bell, share this video. The links for my band One Soul Thrust, as always, are in the description below. If you like what you hear, please consider supporting us on Patreon. Until the next video, we'll see you. Oh, one more thing. The part the amp tech gets to do, usually for himself, the first playthrough.